This is Geometry, Semester 1. It's the third unit called Area and Perimeter. And it's the fourth lesson called Pi. And it's Pi Practice. So it's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So just to give you a heads up on that, you're going to creatormath.weebly.com. Probably have to search to find the site. Here's what the home page looks like. Right? All the composition book stuff is on this home page. Just scroll down until you see comp book and go from there. Follow the directions. But we're going to go to notes, which for this class is under the geometry tab. All of this is vocabulary up front. This vocabulary geometry practice study PDF has every word in it for the entire school year. If you use that, you can get an A on all of your vocab practices. I welcome you to do so. Let's find the correct semester here. Just pay attention to that up front. So for this particular lesson, it's in semester 1. This is the geometry table of contents. You should have copied this entire table of contents into your comp book on pages 2 through 6 a long time ago. If you haven't done that yet, stop what you're doing and copy it in. Make sure you're copying the correct semester into that comp book for whichever semester you're in right now. Let's scroll down and find the unit we're in. So here it is, area and perimeter. It's the third unit. There's 6 lessons here, and we're on lesson number 4 right here. It's pi. These pages are where these notes go in your comp book. Don't look at this video for the correct page numbers. Go to the actual table of contents for when you're viewing this. By the time you watch this, these page numbers probably will be different. So click notes. Sometimes I have to open it a couple times. In this case, it came up on the first time, but don't be afraid to open it a couple times. This talks about a lot of facts about pi, and I'll let you put these in your notes first. That will help you with some of this, these practice problems you're going to do. But things like fact 1, pi is always the same for every single one of an infinite number of circle sizes. Pi is an irrational number which is never ending. It is proof of forever, proof of something which never dies, proof of, yeah, I get a little bit exaggerative there, but possibly, we'll see. Fact 3, the Guinness Book of World Records states that Lu Chao holds the world record for memorizing 67,890 digits of pi. That one always blows me away. Fact number 4, the Feynman point, end quote, is the name of the 6, quote, nines in a row that start at decimal point 762. So 762 digits into pi, there are 6 nines that show up, and it's famous. It's called the Feynman point. I think he's the one that found it first. All right, fact 5, the number is the most, the number 1 is the most commonly occurring number, occurring 10,137 times in the first 100,000 decimal places. That's kind of cool. The Greek letter pi was selected in 1706 by Williams James, an English mathematician, as the name of the ratio. That's why we call it pi, because he named it. Fact 7, March 14 is known as Pi Day, which is also the birth date of Albert Einstein, who was born in 1879. Kind of cool that Pi Day and Albert Einstein's birthday are on the same day. All right, that's cool. Fact 8, the record for discovering the most digits of pi belongs to Fabrice Bellard, who calculated 2.7 trillion decimal places on his desktop computer. Must have let it run for a while. If you Google, quote, a math class about pi, end quote, on YouTube for more fun information, I encourage you to do that. I can only put so much here in this information. Fact number 10, pi is calculated by taking the circumference of a circle and dividing it by the diameter. Pi equals C over D. Circumference divided by diameter. That is in the practice problems for today. Fact 11, where do we use pi? The area of a circle is pi r squared. The circumference of a circle is 2 pi r. Fact 12, don't use 3.14. Use the pi key on your calculator for the most accurate calculations. It's got more digits than just 3.14 after the decimal. Fact 13, Google, quote, the joy of pi, end quote, for more information. Fact 14, Memorize challenge, right? And I don't know, what do I have here? 10, 20, 30, 40, 50, 60 digits. I've had students go way beyond this if they try. So if you want to memorize pi, and we can do a challenge, and then you can get bonus points for that. All right, so let's go to the problems for this one. This one I think is just straightforward. Given the graphic below depicts a famous ratio or fraction. What is being shown? What's circumference of a circle? Circumference is the distance around the shape, right? We call it perimeter if it's not a circle. So perimeter for a circle is circumference, distance around divided by the diameter. Diameter is from one side of the circle or from the circle to the circle through the center. So if you take circumference of the circle, that length, divided by diameter, we get this pi. 3.14159.265 I think are the only digits I know. I just start forgetting it after there, and on it goes forever, and it is an irrational number. Given the following graphic, how is pi calculated? It is circumference divided by diameter. What is a ratio? That's a good question. A ratio is a fraction. So 1/2 is technically a ratio. All right, so we can write it differently. We can say 1 to 2. This is commonly used, the colon in a ratio. But 1/2 is a fraction, and 1 to 2 is a fractional representation. What is a fraction? Okay, a ratio? Okay. All right, so far not too bad. For different circle sizes, pi is the same for all size circles. Right, and we always think we grow up in well, at least I did when I was younger. I'm like, we're growing up in a random universe. Well, certain things in geometry prove to us that possibly this is not a random universe, but things are planned. Things like the sum of the angles of a triangle equal 180. How can that come out true every time for every different size triangle? It seems like it's planned. Same with pi. It comes out the same for every circle size. Seems planned. Potentially, you tell me, right? I'm just throwing that idea out there, and you're deciding where you stand on that issue. Pi is an irrational number, yes. It's not rational, it's not an integer. An irrational number has no end, doesn't die, and never repeats, is unique. Yeah, no repeating terms except no repeating patterns of terms, okay, when it says repeats. One does repeat, like they said, how many times, right in the notes, how many times it showed up in the first 100,000, but it's not repeating in any pattern. So that when it says never repeats means it's not repeating in a pattern, and no end, it never does end. Pi goes forever. So in some contexts, pi is proof of forever. And remember, we always grow up going everything dies. Flowers die, trees die, plants die, people die, you know, everything dies, right? Nope. Pi is proof of something that lives forever. Pi goes on forever. So again, make of that what you will. But that's why math gets studied in philosophy classes, because there are things you can prove through math that you can't prove otherwise. Like, pi would be proof of some sort of context, in some sort of context of eternity. So there is an eternity out there, and we can prove it with pi. So as of this writing, what is the world record for memorizing digits of pi? So Lu Chao memorized 67,890 digits. Wow. Circumference divided by diameter is the calculation of pi. Not E, that's a different ratio we'll deal with later. 2.71 is another ratio. The Feynman point, that's cute because we put it into the quiz here, is the name of the 6 nines that show up at the decimal point 762. All right, that's called the Feynman point. That's in the notes. So a lot of this is just reiterating what the note said. The number 1 is the most commonly occurring number, occurring 10,137 times in the first 100,000 decimals. So there you go. The Greek letter pi was selected in 1706 by Williams Jones, an English mathematician, as the name of the ratio. That's why we call it pi today. He named it, and we stuck with it. What date is Pi Day? Which is also the day Albert Einstein was born in 1879, March 14, you guys, 3/14. All right, 3/14 is coming up, Pi Day. Not that far away, actually, from this recording. Might be far away from when you're watching it. Who holds the record for discovering the most digits of pi? Fabrice Bellard, who calculated 2.7 trillion decimal places on his desktop computer. Now that's a good use of a desktop computer right there. All right, to find out more fun information about pi, more than one answer may apply. YouTube a math class about pi, YouTube that. Google the joy of pi, and so at least pick these two. I know those two are right because they mentioned them in the notes. And these are other facts here, so I'm going to ignore those. Where is pi used? We use it to find the area of a circle, and we use it to find the circumference of a circle, and in other applications. All right, but those are the two main that are going to apply to geometry students. And why do we not use? So this is interesting. You know, we do this in math. Remember back in elementary school, we said 3 times 4 equals 12. Remember that? Every student in high school knows that. Check. But then you got to high school, and x became a variable. So we said, nope, you're not allowed to say 3x4 anymore. Okay, we don't want to see that. That's a variable. We're going to use it like 3x, and we're going to use it in a different context. Now we said you're not allowed to use times anymore. So you have to use 3.4 or 3 parentheses 4 parentheses, right? That means 3 times 4 now equals 12. So we change things on you. In middle school, we teach students, if you have a pi, you know, if you have pi r squared, right, it was area, and say the radius is 3, then we had area equals pi 3 squared, and we would get a equals 9 pi. We would teach you to say 9 times 3.14 and type it into your calculator and get a number. All right, so we stopped that now in high school. Why? Because now by leaving pi in here, this is far more accurate to say 9 pi. So your final answer here is 9 pi. You're going to have some units. Let's say it was feet. It's now going to be feet squared because it gets squared here. And you're going to have 9 pi feet squared will be the answer. You leave the pi in the answer. So that's what this is asking. Why do we not use 3.14 in calculations involving pi? We keep the symbol pi because it is more accurate, representing all infinite digits of pi. I wish this said A-L-L there, all. I think that's what that's supposed to say. It's more accurate to leave it 9 pi. In fact, it's exact to leave it 9 pi. So make sure you're following the name of the lesson to match up where you are, to watch the video with the assignment. Geometry, Semester 1, this is the 3rd unit called Area and Perimeter, and it's the 4th lesson called Pi Practice. It's on creatormath.com under the Geometry tab. Hope this helps.